I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss a very important test question based on congruent triangles. We'll also understand how do we provide a two-column proof. So the important part here is to understand the basics of two-column proof. We'll also take up the different properties of congruency which help us to write the supporting statement or the reason for our statements. Now here is the question for you. ABCD is a quadrilateral. If diagonal AC bisects the angles at the vertex, then prove that the diagonals are perpendicular. A diagram is given to you. Here is a quadrilateral ABCD. The diagonal A to C bisects at the vertex. It means what? It means that these angles are equal. Angle 1 is equal to angle 2. And measurement of angle, let's say this is 3 and 4, is equal to measurement of angle 4. So that is given to you. What you need to prove is basically, then prove that the diagonals are perpendicular. That means the two diagonals which intersect at this point, let's call this as M, they are perpendicular. That is what you need to prove. So let's call this as angle 5 and angle 6. So we need to prove that the measurement of angle 5 is equal to the measurement of angle 6, and since they are perpendicular, it should be 90 degrees. To prove. Is that clear to you? You can always pause the video, answer the question, and then look into my suggestions. Well, in case you want to learn from me, you can always send an email on the address given. Or you can enroll on my website, globalmathinstitute.com. Here is a very special offer. You can join Anil Kumar classes by sending an email on the address given, beginning from $100 per month. Let us now solve this question. So let me begin from a fresh page. You are given that the two angles at A and B are equal since AC bisects these angles, right? So let's again write down the angles as 1 and 2, 3 and 4, and we need to prove that the two diagonals intersect at right angles. Perfect. So the idea is, when we are given that these two angles are equal, how do we begin with? To understand the solution, let us look into what we need to prove. We need to prove that the angle at M is 90 degrees. Let's call this as angle 5 and 6. We need to prove that the measurement of angle at 5, which is the intersection point of the diagonals, is equal to the measurement of angle 6, and that is equal to 90 degrees. Well, we know it's a straight line. So if they are equal, then they will definitely be 90 degrees. This can be done with congruency of triangles. So let us consider the two triangles, one being ABC. I'm shading this So let's say triangle ABC, and the other being the triangle ADC. So what do you notice in these two triangles? Are they congruent? Well, clearly, we are given that measurement of angle 1 is equal to angle 2, and that means the angles are equal. Rather, they are congruent, correct? And on the other side, 3 and 4 are congruent. So, angle 3 is congruent to angle 4. And we know that AC is congruent to AC. And that means that we're talking about angle side angle, right? So the angles, angle side angle, angle side angle. So that means that these two triangles are congruent. So that becomes our first step. So once we show that these two triangles are congruent using ASA, then what does that imply? It implies that corresponding sides of triangles, congruent triangles, is also congruent. Short form CPCTC. So that means that the side length BC is congruent to DC, correct? Now, once we show that, then we can prove that the triangle MBC is congruent to triangle MDC. Right? Since we know that a side is congruent, one side is common, and then angle from SAS. If that is true, then the angle at M, which is angle 5 and 6, they should also be congruent. And since it's a linear pair, each will be 90 degrees. Is that part clear to you? So that is how we could actually show that. Now, the main question here is, how do we write a two-column proof? So that is a major difficulty. So in many cases, students need to understand the properties of congruency and the method of writing a proof. Our focus here is not just the solution of this question, but to provide you a complete solution with two-column proof. So what is important to understand is when we begin with solving questions based on congruent triangles, let's understand that the triangles are congruent if we are given one of these conditions. All sides are congruent, or the corresponding sides mean that is SSS or SAS, ASA, AAS, or HL postulate. HL is hypotenuse leg theorem. Okay, actually it is a theorem. So it is hypotenuse leg theorem. All these three are actually postulates. Now, we also use this concept of corresponding parts of congruent triangles are congruent and short form CPCTC. Then there are 3-4 important properties which you should keep in mind while you are writing your statements. 1. Reflexive property, which means that A is equal to A, right? As shown here. Then we have a symmetric property, which is AB is congruent to DE, means D is also congruent to AB. And then transitive property, if AB is congruent to DE and D is congruent to PQ, then AB is congruent to PQ. substitution property. If measurement of angle A equals to measurement of angle B, and the sum of angles of M and C is 90 degrees, then you can substitute for A, B. And so you could write that measurement of angle B plus C is 90 degrees. You get the idea. So that is how you have to provide the reason for each statement. Perfect. So now, since we understand the solution, let us see how do we really write this solution, correct? So as we are given that these two angles are congruent, angle 1 and angle 2, right? That is given to us. And we are also given that angle 3 and angle 4 are congruent. So if we consider the two triangles here, we are looking at the triangle which is ABC with the other triangle which is not shaded at present. We see that they have a common side AC, which is a reflexive property. AC is congruent to AC, right? So from angle side angle, since these angles are congruent and this side is congruent. So from angle side angle postulate, we can show that the two triangles are congruent. Since the two triangles are congruent, we can draw the conclusion that is, corresponding parts of congruent triangles are congruent, that these two sides are also congruent. Once we do that, then we can look into these triangles, correct? We can look into these triangles. So that's the whole idea. So once we have that these sides are congruent, then the other two triangles, which is the triangle BCM and DCM, they are also congruent using SAS, side, angle, and the common side. So you can actually fill in, just as we did here, the lines, side, angle, side. So congruency. Now using CPCTC, these angles will be congruent. Angle 5 at M and angle 6, they are congruent. Since they are congruent and they also form a line, their individual angle will be 90 degrees, or you can say, very important property here is that the congruent adjacent angles with two lines. So if we have two lines and the adjacent angles are congruent, that means angle 5 is congruent to angle 6, then they are definitely, the lines are at right angles. You get the idea. Using that, we can show that BM, in fact, I should have written that AC is perpendicular to DB, right? So let me rewrite this as the diagonal AC is perpendicular to the diagonal DB. You get the idea, correct? So that is how we are going to show that the diagonals intersect at right angles. So I hope with this, how do we prove and how do we write in two columns the proof of such questions is absolutely clear. So make two columns with statement and reason and provide justification for each and every statement. I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that would be great. Thanks for your time and all the best. Here is an opportunity to learn directly from Anil Kumar. Thank you.